Okay, welcome to this video. I'm just going to do one example of a partial fraction decomposition where you have a irreducible quadratic polynomial in the denominator of your fraction. Okay, so I have this example here, 2x squared minus x plus 4. And this is all divided by x cubed plus 4x. Okay, and I want to find the partial fraction decomposition of this fraction here. Okay, so what I'm going to do is my first step in doing this process is I need to factor the bottom polynomial here. So we need to factor that. So what I'm going to do is factor it. If I notice I have in the bottom I have x cubed and 4x. Okay, well, an x can come out of both of those, so let's factor that. We get 2x squared minus x plus 4 still on top, and then I'm going to factor the bottom, so we've got x, and then when we factor out the x, we divide this by x, we get x squared. Divide this by x, we get 4, so x squared plus 4. Okay, so we now have the bottom factored, which is our first step to this whole process, right? So now that we have this factored, what we can do is look and make sure, can we factor it anymore? Well, does x squared plus 4 factor? Well, it does in complex numbers, but let's look and see. If I were to try and factor it regularly, I would look for numbers that multiply to 4 and add to 0. And there are no numbers that multiply to 4 and add to 0, right? I would need this number to be negative to be able to get a 0 here. Okay, so this is not factorable, this x squared plus 4, at least with real numbers. It does factor with complex numbers, but that we don't need to use that for this. Okay, so we've got x squared plus 4 in the bottom, and x is our factored form. So now what we're going to do is, once we have it factored, we want to write our answer. So we're doing step 2. What will the answer look like? So we want to know what our final answer will look like. So what I'm going to do is I have this 2x squared minus x plus 4 divided by x times x squared plus 4. Okay, and how I figure out what this will look like is by looking at each factor in the denominator. So my first factor is x. That's just a linear factor. So I'm just going to put a number on top, a over x. Okay. Then for the second factor, it's this x squared plus 4. But it doesn't factor anymore, right? And it's a quadratic. Okay. So when you have a quadratic in the bottom that doesn't factor, you will use a linear function on top of the fraction. So you'll do a bx plus c divided by x squared plus 4. Okay, you need to have a bx plus c in order to be able to get this. Otherwise, you won't have enough things going on this side to be able to get this. Okay, so that's our step 2. We figured out what our final answer should look like. Okay, once we know what our final answer should look like, we need to find out what these letters are, A, B, and C. Okay, so step 3. Solve for A, B, and C. Okay? So what I'm going to do, my first thing when I'm trying to solve for a, b, and c is I multiply both sides by the bottom of this fraction here. Okay, so I multiply both sides by the bottom, and I get, or the denominator, I get 2x squared minus x plus 4, right? Because all of this will cancel out when I multiply it. And then I times this by the x and the x squared plus 4. Well, the x's will cancel out. We get a times x squared plus 4. The x squared plus 4 will still be there, but the x canceled. And then for this one, when I times this one by x times x plus 4, or x squared plus 4, the x squared plus 4's cancel out. And so I get plus bx plus c times x. Okay, x is what's left over when you times there. Okay. So we now have a form here that we have an equation over here that I want to try and solve. I want to figure out what a, b, and c need to be. Okay, so what I'm going to do, and what I normally like to do with this, is I plug in numbers to find out what my variables are. Okay, so in this one, and in general, you kind of want to plug in things that make this bottom 0 to cancel out some of the factors that you have going on here. So this one is actually never 0 with real numbers, so that doesn't really help me. But this is 0 when x is 0, right? So I'm going to say set x equal to 0. When I do that, this goes to 0, this goes to 0, this goes to 4. So we get 4 equals, this is 0 plus 4, so 4a. Okay. Then this is 0, this is c, and then 0, so that's all. This is all 0 here, sorry, excuse me. So this is all 0 when we plug in 0, so I just get 4 equals 4a. Okay? So what does that mean? That means that a equals 1. Okay? So that's one of the variables that we need to find. We found a. Okay? Now we need to find b and c. So what I would do here is I would plug in another number. The only issue is we can't really plug in any numbers without, well, to make this a really nice equation to do. I'm going to set x equal to, and you can pick whatever you want. Maybe I'll do x equals 1. Okay? So when I do x equals 1, I get 2 minus 1 is 1, plus 4 is 5. 5 equals, well, 1 plus 4 is 5, times a is 1, is just 5. And then b times 1 plus c, so b plus c times 1, so b plus c. So in other words, I get this equation. I'm going to just get the 5 over to this other side, so I'll subtract 5 from both sides. I get 0 equals b plus c. Okay? Now that doesn't help too much because I still have to figure out what b and c are, but at least I have one equation that relates b and c together. Okay? So now I need another equation so that I can solve this. Okay? So let's plug in another number. What should we do? Maybe -1? I'll do x is -1. Okay. When I do that, on this side, I get 1 times 2 is 2, plus 1 is 3, plus 4 is 7. 1 plus 4 is 5a, which a was 1, so we still just get 5 there. And then plus, we place x with -1, so b times -1, we get -b plus c. And all of that, sorry, we'll maybe extend this out a little bit, times -1. Okay, so just everywhere there's an x, I put in a -1. And what happens when I do that? I get 7 equals 5. Let's distribute in this negative. We get a positive b and a minus c. So let's subtract the 5 over. Okay, so we get b minus c is 2. Okay. So you'll notice here I have two equations that I've got for b and c. This one right here and this one right here. Okay, so I have two equations with two variables that I need to find. Now I just need to find them. Okay, so let me get a fresh sheet of paper here. So the two equations we found were they were 0 equals b plus c. And the other equation we found was 2 equals b minus c. So how I would solve this is I would either use substitution or elimination. Okay? So in my case, I think elimination would be pretty easy because these are already opposites of each other. So I'm going to add these two equations together. And we get, these two add together, we get 2 is 2b, or not 2b. And then we would divide by 2. So we get b is 1. Okay? That's good. Now, we just need c. So I plug back in b. We get 2 equals 1 minus c. So I could subtract 1 over. I get 1 equals negative c. And then times that negative over. So -1 is c. Okay. So we just found a, b, and c. Okay. So if we kind of remember here, let me slide this a little bit. Our original answer that we were looking for was this right here. Okay. We were wanting to figure out what the partial fraction decomposition was, so we figured it out. We found out that a, well, that was on the previous page. It was 1. A was 1, so my answer would be 1 over x, because a was 1, plus b. B was also 1, so we got x, and then c was -1, so we get x minus 1 divided by x squared plus 4. So that's our final answer there. Okay. So hopefully you're starting to get a hang of this process. Really, you can plug in any numbers you want to find a, b, and c. Usually you just pick one so that some of the factors will be 0, but sometimes that won't work. So you have to plug in just other numbers, just random numbers, and you'll get a system of equations that you can solve. Okay? Well, have a good one. I will see you in the next video.